Hello everyone, welcome to my channel. Let's learn computer science. Okay, today's topic is hexadecimal to denary conversions, right? So, hexadecimal to denary conversions is something that we are going to learn today. Now, to give you a syllabus reference, so it is mentioned in your syllabus that convert an integer value from one number base representation to another. And number systems mentioned are binary, denary, and hexadecimal. So till now, you have learned how to convert binary to uh, decimal to binary to hexadecimal, right? This also we have learned in previous videos, and also hexa to binary we have covered. Now, today we are going to learn about how to convert a hexadecimal to denary and vice versa, right? Let's start with hexadecimal to denary conversion. Now, method is same. I'll take one example and we'll show you the method by solving that particular number. So we'll convert 5a, which is an hexadecimal number, to a denary number. Okay, so there are two methods I'm going to explain. Let's start with first method while converting hexadecimal to binary. Okay, so we write as part of first method, we write number first, individual bits of the number we write as it is. Okay, then we write their place values. Okay, so 5 and a we have written, their place values we have written. Now, what we'll do, we'll multiply place value with the individual digit. So 16 raised to power 0 is 1. Okay, and this place value is 16 raised to 1, which is 16. So now we'll multiply individual digit with its place value, right? Now, a is, whenever we have to do some calculations, a will be taken as 10. Okay, that we have covered already in the previous video where I showed number systems, various number systems, right? Now, as part of this method, we'll multiply each individual digit with its place value. So 16 raised to power 0 is 1. So 1 into 10, a is 10. So 1 into 10 gives us 10. Okay. Now here, 16 raised to power 1, which is 16 into 5, which gives us 80. Now, the result will be added. So 80 plus 10, we'll add this 80 plus 10, which gives us 90. So 90 is our answer. So this is our first method where individual bits are written and individual bits are multiplied with their place value. Finally, the result is added together to give us the final denary number. Okay, we have another method also to convert hexa to decimal. So as method 2, what it says, convert hexa decimal number to binary first, okay, and then convert that binary result to denary. Very simple. So we'll convert the hexadecimal number into binary first, and then we'll convert the binary into denary. Okay, so I'll show you the same example I'm going to use here also to show you how to convert hexadecimal number into denary, right? So 5a, firstly we'll convert to binary. Okay, so for a is 10 and its equivalent binary is 1010. You can use that table again, reference table, conversion table that I showed you in the video about number systems, right? So a is 1010 in binary, and 5 is 0101 in binary. Now this is binary equivalent. Now this binary number, I will take it as a whole. This binary number will convert it into Denary. So I'll put it here using the place values, and all those place values will be added wherever the number 1 is written, right? So I have written this here, I have written this here, and then I have added all those place values wherever there is a 1. Okay, so 64 plus 16 plus 8 plus 2, which gives us 90. And it is same as the answer that we got here, right? So that's all as per the second method. Now, our next topic is how we can convert a denary to hexadecimals, right? So I'll show you this also using two methods. You can use any method, whichever method you feel comfortable with, or whichever you find comfortable or easy, right? So as per first method, what we do, we'll convert the given denary number into its binary form first, and then that binary number will convert it into hexadecimal. Easy. Now, the same value I am going to take so that we get to know whether our conversion was correct or incorrect. Okay. So 90, we are going to convert it into hexadecimal. 19 denary, we are going to convert it into hexadecimal. So as per first method, firstly, 90 will convert it into binary. So here, as for 90, equivalent binary is this. Okay. You can use the previous video where we learned how to convert a denary to binary. So denary to binary, this is the equivalent of 90 in binary. Okay. Now, to convert this binary to denary, we'll follow that method, how to convert a binary to hexadecimal, where we make a group of 4 bits, and then for those group of 4 bits, we write the individual hexadecimal value. So this we have converted into 4 bits group, right? And here, because there were only 3 numbers left, so I have added a 0, and its equivalent is 5, right? And equivalent of this is 10. For 10, we all know 10 is equivalent to A in hexa, so 5A is the answer. So that is what here we started with. So 5A is 90. So as per first method, we have got our answer equivalent to the above. So very simple. First method, firstly convert denary into binary, then whatever binary number we get, we convert it into hexa. Yeah. Okay. Now second method. Now second method is also very simple. Here we'll use division by 16 method. So whenever you have to convert some number into from denary into some other base, so simply divide by that base into which you are converting from denary. So if you're converting from denary to binary, you'll divide by 2. If you're converting from denary to hexa, you'll divide by 16. So here we are converting to hexadecimal, so we'll divide by 16. Okay, so 90 is the number that in denary that we are going to convert into hexa. So we are dividing 90 by 16 continuously till the time here we get a quotient less than 16. Okay, so we divide this by 16. So 16 fives are 80. So we get remainder as 10. So remainder we are writing here, and quotient we are writing here. And as 5 is less than 16, so no more further division. And we simply write the answer by starting from down to upward side. Okay, so 5, and instead of 10, we are going to use A here in hexa. Okay, so 5A is the answer, which is the answer we get here. So our answer is correct, right? So this is the second method, division by 16. Okay, now we'll have a look at a few past paper questions. Okay, so this is a past paper question from 9611 paper component, October, November 2022. So series October, November, year 2022, and paper component is 119618. Okay, so question here is convert the unsigned binary integer into denary. So very clearly mentioned unsigned. So you don't have to worry about any sign. There is no sign associated. So unsigned means a positive number. Okay. So number given here is 001001111. Now they have not asked for any working, but I have I have showed working here so that you understand how I have reached to this conclusion. So you simply have to write the final answer here, right? So binary to denary. So what I have written, I have just simply written the number here. Then I have written the place values up there, and I have added all the place values wherever there is a 1. Okay, so 1 is under 32, under 4, under 2, and under 1. So I have added 32 plus 4 plus 2 plus 1. So answer is 39. Simple. In case they ask you to show the working and they provide you with the working space, you do show your method because in the marking scheme, there is mark associated with your working also. 1 mark will be for the answer and 1 mark will be for the working. So always show working wherever working space is given, right? Next question is past paper question from 961812 October November series year 2022. Okay, here also they have mentioned convert unsigned binary integer into hexadecimal. So unsigned, again, it's a positive number. You don't have to worry about the sign. So number is 100101110. Okay, and you just have to write the answer. You don't have to show the working. However, for your better understanding, I have written how I reached to this conclusion. I have written it here, right? So what we do, we just make group of 4 bits and then we write individual number corresponding to that group of 4 bits. So 1011 equivalent to 9, 0110 is equivalent to 6. So our answer is 9, 6 in 16 in hexadecimal. Okay. One more question. This is question from 961811 component May June series year 2022. See, here they have given you working space. So you have to show all your working here. It is of 2 marks and 1 mark is for the right answer and 1 mark is for the showing of working, that how you have reached to the conclusion, how you have reached to the final answer. So if you do not show working, you will not get full marks. You have to show working as well as you have to write final answer. Okay, so here they have mentioned denary number 251 is to be converted to hexadecimal. You can use any method. I have mentioned 2 methods up there. You can use any method. So here I have shown I have written this method, division by 16, right? So 251, I have divided it by 16 continuously. So till the time I get a value here for quotient less than 16, I'll stop my division there. So 251 divided by 16. So 16 into 15 is 240, right? So remainder is 11, which I have written here. Okay, so 15 is less than 16, no further division, and will just write my answer starting from downside going upward. So 15 is equivalent to F and 11 is equivalent to B. So I'll write here FB as an answer. You'll only get full marks if you show your working as well as you write your final answer. Okay, so that's it. So in today's session, we have covered we have covered conversion from denary to hexa and hexa to denary. With this, this topic is also covered, right? Now, in upcoming sessions, we'll learn about BCD and 1s and 2s complement representation. So these are the topics which are left from this syllabus reference. snapshot, right? So thank you